Okay, what my theory and what you'd like, just think about this for a minute. What if everything in the universe, including the strong force, is consumption, supply and demand? The dielectric is the supply, so it's basically infinite. The demand is mass. The atoms of mass are the demand, which is what I call the electron function. It's not an electron orbiting the atom. It's pings of the charge, the dielectric charge, electrostatically holding atoms, quarks, particles, and quarks and atoms together. So I'm going to use some BBs with this DC adapter. It's just 10 volts, 700 milliamp DC output adapter. Here's the ends I'm going to use on these BBs, and we're going to do that. Then we're going to get onto some larger pieces, these steel ball bearings with a larger battery, and show you how I say the strong force works. It's supply and demand, it's consumption. It's a constant consumption. And the electron is an electron function of static of dielectric charges pinging the parts of the atom, and it goes around pinging, and it just looks as though there's something orbiting, but it's the dielectric charge. I call it the electron function. And we'll move on. Okay, well, I've got the 4 BBs here and my power source, and I'm going to show you what I believe is the strong force. So these BBs, once I energize them, they were stuck together, if you noticed. I'll do it a time or two so you believe me. Once you energize them, they get magnetically or electromagnetically locked. So them two are locked. Maybe I can show you now. These two are not, but these two are, if you see that. They roll together, they're stuck together magnetically. See that? Then I can touch them and they come apart. I can do it a time or two. I've seen guys on YouTube do this with bolts and nuts, and you can do it with those with the higher power, but I want to show you how with something very small, it doesn't take much charge to do so. And if I get it just right, get it back where you can see it. And I've charged those two together. Not these two, but those two. Let me find a pointing device. Something that's not going to move it around. But if I move those two, they move in unison, if you see that. They move together until I break them apart. So the electrostatic bond is there as long as they're not moving. So here's the BBs. I guess you believe me. You've seen this. I'm just doing it at a smaller scale on purpose so I can move the scale up. But you see how they bond, and they'll stay bonded until something like vibration or certain movements unbonds them. I've got these two bonded again. Let me back the camera up a little bit. And then I can show you, they just roll together, if you can see that. Let me bring them back this way. There they are. They just roll together. And then they break if they're hit hard enough. Okay, so that's the first part of this. To me, or to my explanation of the strong force or the electron function, is the dielectric charge is a vibration. These are just the right frequency where they'll work together when they're vibrating near each other. It uses a surrounding charge to electrify them, electrostatically bond them temporarily. But there has to be, they keep compiling until you get enough of these together, which will compile to make something bigger, which I'm going to consider this a quark. These are way too big for the particles I'm talking about that make up quarks, but you see how that works. 2 bond, 3 bond, 4 bond, or 2, 4, 6, 8, however they bond. Then they'll come up to something almost this size. They get to a certain number of them, and that's when you have separate quarks. They don't get any bigger. The 4 quarks come together. I'm going to show you this in a little bit. When the 4 quarks come together, that's when you get an atom of hydrogen, 4 quarks. And those come together from a bunch of these making up each quark. I don't know how many, but we know there's 4 quarks in an atom, and the electron spin. And I'm going to get to that next, the electron spin. But it's the same thing that's holding the particles that make up the quarks is the electron function, is what I call it. It's just the dielectric charging them over and over and over and over. But we can't see that, but we see what happens with a atom of mass, an atom of hydrogen, and we call it the electron. But I call it the electron function, and I'll show you how I think it works next. Okay, now our BBs have all come together to form 4 individual quarks. So let's just say this is 4 quarks, 1 hydrogen atom. And since all the BBs in each atom, all the particles, which they're smaller than nanoparticles, so for the BBs to make up one of these ball bearings, it's going to take millions of them, okay? Hundreds of thousands to millions or what have you to make these 4 quarks up for our hydrogen atom. But once it gets to this size, each quark, they're all vibrating at the same frequency, at the same vibration. And they're unison, so they're a bigger particle. But when 4 of them come together, the number's just right to where these will come to get the electron function, which what I mean by that is the charge that's coming in to electrify everybody into holding together is much larger now. Let me show you. You've probably seen this also on the internet, like I said before, using bolts and nuts and what have you. Now I've got a 12 or an 18 volt battery here, my 2 leads. I'm going to try and do the same thing with these 4 ball bearings as I did with the BBs. Just give me a minute here. Just give me a second. I about had it. Okay, what I've got, all 4 of those are locked together. If you see that, if I push one, they all 4 move. They're not rolling, they're scooting. Okay, they're locked together. And if there was no force against them, they'd stay that way for I don't know how long, a very long time. As long as I don't bump them hard, they stay locked together. I can push them in any direction. Now they broke apart. The point is, that is the electrostatic bond, which what I say is the electron function. It's the dielectric charging these 4 quarks like that to hold together. But it does it a positive on the left, negative on the right. It'll start here, then it'll move to these 2, then they move to these 2, and it goes around it. Positive to negative, positive to negative, positive to negative. And I'll probably show you a little animation of how I see that happening. Positive, the negative is the 3 others being pulled to that positive. And the positive will move to this one, and those 3 are pulled to that one. And the positive moves to this one, those 3 are pulled back. The positive moves to this one, and those 3 are pulled that way. And it goes around, keeps doing it, because everything's vibrating, so it's going to knock them apart at that small size and state. So we have to keep doing it to keep them pulled together. The reason it looks like an electron orbiting is because it's moving around it. 1, 2, 3, 4, 1, 2, 3, 4, just repeats, probably at the speed of light. And another thing that people don't realize, or what I'm going to assume here and put out, is that this charge that's hitting those is kind of like sprites above a lightning thunderstorm on Earth. The sprites are way up in the atmosphere, then it comes down and hits the clouds, then you have lightning to ground. The electron function happens way out here, way away from the atom is where we see it, but it's actually coming in and sparking them together, like so. It's actually coming in from way out here it's sparking them together, almost like dark mode plasma at a small scale, and then you have them stuck together, if you see that. And then they'll break apart. But the vibration probably breaks them apart as soon as they get stuck together, and that's why there's another function that has to happen right away, and that's why it swirls. And these charges are probably rotating as they come in. They're probably not just a straight shot, it's probably rotating. The positive is probably rotating coming in as it changes from each quark all the way around it. At the speed of light, it gives the illusion that this thunderstorm sprite is orbiting, but it's not. It's going from, it's just a charge grounding from quark to quark to quark to quark, quark to quark to quark to quark. 1, 2, 3, 4, 1, 2, 3, 4 at the speed of light. You can't even see it. It looks like something is orbiting. I want to get from that how I see this as to how that bond, electrostatic bond, not only holds atoms together and molecules together because they share this charge. The charge may go through hundreds of atoms before it, gets organized. And once it's organized, then you have a molecule, or you have a piece of steel, you have something of mass. It's organized in a choreographed electron function that works together. And it's a saturation once they become mass. So I'm going to move on now to show you how I think that works into mass and into magnetism, natural magnetism, and we'll do that. This is my take on how the electron function works. If you see here, it's going around in a systematic or chronological order, 1, 2, 3, 4, 1, 2, and it repeats. But if you watch, it's going to speed up here. There's a little faster, and this happens at the speed of light, I believe. It's supply and demand now. Ether, dielectric supply, and mass demands it. And it's so fast now, you just see it's flashing. It just looks like it's flashing, but it's actually orbiting. 1, 2, 3, 4, 1, 2, 3, 4. That's why we think the electron orbits. Okay, as I've stated, my take on it is the universe works on supply and demand, as I said before. But what I've got here, I'm going to show you what I think this does, what magnetization does. I've got a microwave oven transformer. The top's off of it. The top windings off of it, coil. I just have the main coil and a switch. Kick it on and off. Here I've got a magnetizable piece of high carbon steel. It's painted to be a magnet, but if you notice, there is no poles or anything on it, and I'm going to show you in a minute. It will have. And what that's going to represent when it's not magnetized is like this little green block of wood. It's just there, okay? When I do magnetize it, that's going to represent this wood, blue and red block of wood. And we're going to do something with these blocks of wood here in a little bit after I do this to show you. So I'm going to try and catch it where this magnetizes north to south, because this is an AC current. So as that spins back and forth through this coil, the magnetic field jumps over these poles of the W in the core this way, then that way. So I never know which way it's going to magnetize it when I let off the switch. So let me show you. Let me magnetize it. 1, 2, 3, buzz. And let's see if it did it right. I did. I've got north and south. If you see, north and south. So all I did, according to my theory, is take normal gravity penetrating this, its consumption, the normal gravity consumption, spherically radial, penetrating it to its core all the way around it. I've changed that. Instead of it going that way, it's now going through it from both ends towards the center. It's no longer coming in along the surfaces here. It's always coming in through the ends, because this forced it to rotate in a spiral in this way and a spiral in that way. That is the difference. It's just all I did here was change how this accepts its dielectric strong force feed. That's all I did. I changed how it accepts it. And it has to accelerate to maintain. It's not just the rotation on the ends. Why would it remain that way? Why would the atoms remain in a rotating situation? Why would the ether remain rotating if there's nothing to create that to stay? It takes energy to keep that doing that. You can't do it just from one time and be like a flywheel. It just it can't. I don't believe it can do it. I believe it's supply and demand. I've just changed the way this is supplied. Now we'll move on to showing you how that relates to how it works, why it accelerates to give such a magnetic field, and why it does what it does. And we'll do that. I just wanted to make one more clear shot of this. And I said, this is my take on how the strong force, gravity, magnetism, energy, electric currents, combustion, nuclear fission, fusion, and even radioactivity is all rooted from the dielectric charge, the ether charge, how it is penetrated to mass, how it's doing it, and what the mass is causing it to do. The mass is just being penetrated normally on a non-magnetized piece of steel or neodymium material. On this, the mass is forcing it to penetrate from both ends. That's why you see the energy you see from this is because of the acceleration. It's vortexing and it's accelerating. So I just wanted you to look at those two kind of side by side. This is my take on it. Take it or leave it. And we'll move on to more why this accelerates just because it's coming in the ends. And I'm explaining I want to do it with these again before I move to the other. The time it takes for each one of these to reach the center is equal to where they all balance to reach the center of this block of wood to hold it together. They're all equal. But since this one doesn't have any up here to shorten that distance from the outside edge to the center all the way around it, it's only coming in the ends and it's vortexing. It has to accelerate to get there. It's got to get there to keep those electrons moving, keep that electron function happening, keep that electrostatic bond of the atoms going on. And since it's restricted on how it can penetrate, it has to accelerate to get there. Time versus distance, and we'll show that next. Okay, now I want to show you with my best demonstration I can why when you magnetize a piece of steel, you get acceleration, which is what shows the magnetic field that a coil shows. But the electric current's already accelerating. You're just doing it in a loop to make it magnetize. And this does the same thing the inside of the coil is doing. So that being said, I have a tape measure here. And if you notice, I got little pieces of these tubes. It's tubing. It's like aquarium tubing, okay? And I've got them, three little pieces about 1 inch long. And they're going to represent our nails here. And like I said, this is crude, but it'll explain what I'm trying to say. So each one of these nails is going to be like a 1 inch tube. So I've got 18 of them on each half of this piece of wood, but it's a non-magnetized piece of steel. So there's 18 nails on each end, and that'd be what, 36 nails that this is experiencing as its dielectric charge to feed its electron functions, its strong force. That's just like I said, it's a saturation, but I'm trying to use nails and these tubing to show you how my theory explains it. So we've got 18 of these little short tubes going to the center of this wood. So each of the 18 only has to pass so much dielectric in as a saturation, if you see what I mean. It's a saturation, but I'm just using the tubes and the nails to show you it's all along it, coming in all the way around it. Spherically radial, centripetal penetration. So all these are tubes now instead of nails. Little tubes flowing in dielectric to the center of this wood to where it meets itself, and it gives it its strong force all the way in. It's relayed in, and this is getting its strong force no problem at a certain speed at what it needs, spherically radial, receiving that penetration, supply and demand. The supply is always there. The demand is what you see. However, when we magnetize, we're taking those 18 nails on this end and the 18 nails on that end, and we're putting all 18 of those nails coming in the end. And when it does that, it vortexes. So, time versus distance, these don't have to pump that much in because there's so many of them coming along it, all around it. They're all coming in, these little 1 inch tubes. It's a saturation, like I said. They're bringing the dielectric in all along it, so it's a slower rate. We don't even notice it. Pole finder won't find a pole here because there's no acceleration above what it needs for what it is. But when we bring it in the end, the reason it accelerates, we have to get from here to here from the end only. And it's vortexing as it does that. So it's like if I had to wrap this tube around this block all the way up and then feed it in from the end. Look how long that is. Look at the length as opposed to these, which are just 1 inch all the way along. They're easily working together to fill it full of dielectric. This has to fill it from the end only. That's why it accelerates. To get to this end, it has to pump it in faster, and it spreads out as it goes to fill all those atoms, their dielectric strong force, the electron function. In this fashion, the vortexing linear feed as such, it has to do it that way rather than spherically radial centripetal that way. As this comes into the middle, it has to accelerate as it throws it out to each atom until it gets to the middle. And it's doing it from both ends. They're meeting in the middle. The south side's doing it its direction of rotation. The north side's doing it in the same direction of rotation, but it's coming in from the other end. That is why there's acceleration. It's got longer, look how long that is to go to get the same distance each one of these individually does. These individually do it normally. When you magnetize, you're taking those individuals and making them into a vortex and making it longer distance from here to the middle and from here to the middle than from the outside where they all meet in the middle. That distance from the vortex that long coming in each side is a lot easier than a bunch of small pieces, see? These don't have to be added together in one tube. They're all working independently together. Here, it's not all working independently together. They're all working together as one. That is why it accelerates and vortexes. It has a farther distance to cover because they both have to have that strong force happening instantly. And it can't do it at a slower speed here. And I'm going to show you one more thing that explains this, and then I think that will be it. Okay, the last thing I want to show is if you just take a slice of this, and all along it is working the same way all the way around. You've got 4 1-inch tubes or nails meeting in the middle. So each one of these has a very short distance to go. If you see that, it's got 1 inch, 1 inch, 1 inch, 1 inch, but they're all working together at the same time from different sides of the mass all around it. It's spherically radial. They're working from different sides of the mass at a slower rate to meet at the middle. This is not. This is how long this has to get fed. The dielectric has to move that far, this distance, to get to the middle, where this doesn't. Each nail is individual here. Each one of these are individuals working together. This is not. This is actually spiraled along into the magnet like so, spiral vortex, but that's how long, if you stretch that vortex out, that's how long it is getting from the end to the other end. On both ends, they're coming towards each other. I'm just showing one side. Time versus distance. So for that matter, let me move 2 of these. If you see the difference here between distance, how long would it take for an air molecule or a water molecule to go from the end of this tube all the way through to the end of that tube, or as opposed from the end of this tube to the other end? In the same amount of time, this is going to make the same, this is going to go through, but this will not. It'll make it 1 inch down in the same time frame, right? At the same speed. If they're both moving at the same speed, an atom of air or an atom of water or a molecule of water, and moving through this at the same speed, this will take 1 inch of time, and this will only go this far in 1 inch of time. So it's not to the end. It's not feeding all the atoms. This has to go at least, in this particular demonstration, which is not numerically correct, this has to be 18 times faster than the 1 inch. You understand? It has to go all the way through this tube at the same time that it goes through this little tube. That's why it accelerates and it vortexes. It has to make it that 18 times the distance in the same amount of time. So it has to really go fast to make it in the same time this would make it through. So for the time it takes this to go through, this has to go through in the same amount of time. So that's why there's acceleration. That distance has to be made up one way or another. Since it's not made up this way, it has to be made up with acceleration. If this was driving one tube length at 10 miles an hour, you're only going to get 1 inch of that in this tube at 10 miles an hour. So, in other words, if this one's going 10 miles an hour, this one has to go what? 10 times 8, 180 miles an hour. 18 times, more than that, if you get my drift. The acceleration has got to be there because of time versus distance. They have to equalize in time, but there's a difference in distance. Let me know your thoughts.